Good afternoon, everyone. Thank you for joining this webinar. Today, together with my colleague Milat, Denise, and Tanvir, we are very proud to give you an overview on our brand new release, 10.9, which has been released last week and which is now available for download on our website if you have a valid subscription. So during the next 30 to 40 minutes, I will give you a short introduction about Diana to start with, and we will basically go through the new features and announcements that have been added to our new version 10.9. As usual, during this online presentation, your microphone will remain muted, but there is a question box. You can type your question there, and from time to time, I will keep an eye on this question box. And if the questions are relevant for the whole audience, we will try to answer them at the end of this session. This webinar will be recorded, and within a few days, it will be available on our YouTube channel. So if you want to replay it, keep an eye on our YouTube channel. Having said that, let's start with this presentation, and let me first give you a short introduction to Diana before we move to the new announcement and development in terms of modeling features, material model, analysis and results, and also regarding our online tutorials and the documentation. Diana is a short form of displacement analyzer and is a general finite element program which is dedicated to all types of civil, geotechnical and petroleum engineering applications. Our aim is to provide a range of efficient engineering solutions to the daily or specific type of engineering problems, but by increasing the accuracy of the final results, our clients could optimize the cost of their project. Our core values of our companies are presented on these slides, and I would say based on the trusted relation with our clients and partners, we try to mature dynamic and innovative ideas to deliver state-of-the-art solutions and quality service in a world-class product. So I would say that's our main motto on a daily basis, and we are very happy with what we are doing and what we are delivering to our clients, and also happy in the trust that our clients put in our product. Let's quickly go through the different Diana application. We start with geotechnical and tunneling. We have a very good integrated solution for all types of geotechnical and tunneling applications. So you can use the integrated environment of Diana for any types of tunneling and underground structures. We have a solution for ground freezing called the three-phase analysis, for real soil structure interaction as well. So if you have some sort of interactions between the underground and the surrounding soil or rock, you can model it with the concept of nonlinear interface behavior. We also offer the couple groundwater flow or heat stress analysis, and many more, such as slope stability. So we offer quite a variety of solutions for the geotechnical and tunneling. Next to that, we have a very comprehensive solution associated to reinforced concrete and the young hardening of concrete. So that's mainly when the model and the casted concrete goes through the process of hydration. We offer this solution for any type of concrete box here that are composite structures. For dam structures, it's also very important because of the process of casting, curing, hydration, and impounding. We have also a good coverage for design check, including the reinforcement based on the Eurocode, mobile load, and the design load generator, and also the cross-section design check. If temperature is important, we have a temperature and stress coupling. So that lets you analyze how the concrete goes through aging. We have cooling pipes, which is also another powerful feature that we offer in both 2D and 3D in order to control the iteration process. Crack initiation and propagation in concrete, it's one of the powerful features in Diana. And also fire effects, so how the fire could affect the durability of your structure, for instance. Among other applications, we can refer to masonry and historical construction. In Diana, we offer different solutions at meso or macro level, so you can use Diana to model the interaction between the individual bricks and the mortar joints, for instance. For dams and dikes, Diana offers this solution. It covers all the aspects of construction for all types of dam structures. So you can consider the fluid structure interaction or dynamic effect, and also the induced damage to the structure. Fire analysis is another area where, based on its importance, has become one of the main topics for structural check. And again, Diana can be considered as one of the most reliable solutions. For earthquake analysis, you can use Diana for general dynamics or seismic. Among the advanced type of application, Diana is also very well known in the field of oil and gas and nuclear structures. So based on the type of complexity, you can simulate 3D geomechanical depletion or borehole stability. For nuclear structure, you can analyze concrete containments or underground waste storage, for instance. So after this short introduction, let's move to the basically enhancement and new features that we have introduced in 10.9. And one of them is the enhancement of our spatial functions. In previous Diana versions, so up to 10.8, it was only possible to define these spatial functions in Diana IE as a function of one parameter, whether x, y, or z, or a pair of parameters, so x, y, xz, or yz, in the matrix format. Now, it's in 10.9, it's possible to define them in by means of three parameters, so x, y, z. And there is also an enhancement in terms of graphical visualization. So you are able to display your 2D or 3D functions in a graphical window, which is now part of our function window. When you go for 3D functions based on the XYZ parameter, basically for every Z coordinate, you have a XY grid associated. So it's a very comprehensive way to define your function. So I'm going now to pass the microphone to my colleague Milad, who is going to talk about the composed element. So Milad.
Well, good day, ladies and gentlemen. Here I'll be talking about composed elements. As you may already know, composed lines and surfaces are used to obtain internal forces when continuum elements are used. Diana performs integration over the elements that are assigned to a composed element. Previously, there were two ways to control and filter which elements can be assigned to a specific composed element. First one, which is through the geometry of a composed element, is basically a range around the cross-section of the composed element. The second option that we had is through the output box, where you can include or exclude different types of elements. In a new version of Diana, you have also the additional third option, where you can select element sets at the geometry level during your modeling. Can we go to the next slide, please? It is important to note that none of these filters are mandatory. So if none of them are defined, the whole model will be used for the calculation of forces and moments. But if you choose more than one of these filters, the intersection of these filters will be used to define which elements will be assigned to the composed element. Next slide, please. And to do it from Diana IE, you just easily select the composed set from where you can define reinforcement sets and piles and anchors and these kind of stuff. And then if you double click on it in the properties section, you have the right figure, and there from data tab, you can add whichever geometry that you want to be assigned to that specific element, composed element in the list. And that will be it for my part, and I will give the panel to Denise.
Thank you, Milad. So I continue with new developments regarding modeling. This is the ambient time dependencies for beam and shell elements. So in previous Diana versions, we could do this, but only through the .dat file, through syntax, which is not so easy sometimes. So now you can do it through Diana IE. And for that, there's an extra parameter. You will see in the Edit Ambient Time Dependency panel that the parameter of mesh type. It was not there before. So now you have two options for this mesh type. It is nodes or elements. For the nodes mesh types, it is for all the elements that was already possible in Diana. So continuum elements like stresses, plane stress, plane strain, axisymmetric, and solids. The new thing now is that you can put also ambient time dependencies assigned to beam and shell elements, and those will be under the elements mesh type. When you select elements mesh type, you will need to define the element class, and there you will see all the types of beams and shells. This is connected with the previous one, so is to easily or faster, in a faster way, assign these ambient time dependencies. Because the ambient time dependencies, you need to give the parameter of temperature, maturity, concentration, for each timestamp, and sometimes you need to do that for different timestamps in the same geometry. So we added in 10.9 the duplicate icon, so you can duplicate these entries of ambient time dependency and keep the same geometry and just edit the timestamp and the value. So it's very helpful. Next slide, Jean-Claude. Thank you. Another topic is the spatial functions in some loads that was not possible before. So in the previous versions of Diana, you could assign spatial functions to a sum of the loads, but it was not possible to assign to prescribed strain loads, element pre-stress, and incremental temperature and concentration loads. So this was only possible through the .dat file, so through syntax. And now in Diana IE, we can do this. So you will see that when you select the load type of prescribed strain or element pre-stress or incremental temperature or concentration load, at the end of the panel, you will see the spatial function that you attach to this, the parameters. Now, sorry, Jean-Claude, yes. So here I wanted to say that for example, for beam elements and shell elements, you will have parameters for both average and gradient values, and this spatial function will be attached to both of them, the average and the gradients. If you only want to attach to one of them, only to the average or only to the gradient, you can make use of combinations of loads and then combine as you want, with only spatial function to average or different spatial function to average and gradient. Thank you. So now the next. Another nice feature for modeling is that, well, when we have these large geometries, complex models, and we need to assign different properties to the same group of geometry entities. So it can be vertexes, edges, faces, and shapes. So in the different modeling steps, we need to select over and over again, multiple times, the same entities. So now in Diana 10.9, you can save a selection. So for example, here we give this example that there are some edges selected to attach support. And so you can select the edges, and this is a lot of small edges. So you select them and you can save this current selection. And then you can reuse it and go again to the main menu, viewer and selections and user defined selection, and pick the one that you just saved, and then use it to add more properties to the model. So this makes the modeling experience much faster and nicer. And the next, Jean-Claude. I pass the word to my colleague Tanvir.
Anun?
We hear you, Tanvir, you can proceed.
Yeah, thank you, Jean-Claude, and good afternoon to all. Next new modeling aspect is related to automatic tyings. In the past, Diana didn't allow shell to solid automatic tying possibility when the shells are intersecting with each other. Now we also allow that, and that then it is just enabling this shell to solid connection for more complex configurations. For instance, we can make a T-shaped cross-section like configuration of shell to a solid surface. Next slide, please. Element pre-stress load. So this was already existing in Diana for many years, but it could only be applied in a stress initialization scenario. And now this element pre-stress load has been made more general, like any other loads. So now it can be defined as defined in load execute block, also in start execute block as added load, and then they can also be used if it is defined in a load execute block. Then it can also be used in a time function, so can also be used in transient analysis. The shortcoming of previous situation where it could only be used as stress initialization procedure is that if we have multiple phases, then stress initialization works only for the new elements. And then we don't have a possibility to apply pre-stress load in an existing element. But now this limitation is gone. And one example application could be for external tendons where pre-stress loads are used. And it is very general. It can be used anywhere with more freedom now. Next slide, please. Yeah, it is somewhat in the same line. Now it is the pre-stress in bond slip reinforcement. Pre-stress in bond slip reinforcement was not at all possible in the previous Diana versions. Now we can make it, and it makes, and also it is now can be used also in load steps, not only as stress initialization. and it makes post-tensioning with bond slip reinforcement much easier. For instance, when in the past we didn't have this possibility to apply post-tensioning with bond slip reinforcement, we had to pull the two ends of the tendon or the bond slip reinforcement with a nodal force. Then we also had to apply equivalent reaction force at the end of the beams, and then finally we had to tie them. Now all these things can be simplified. We only need to define anchors at two ends of the bond slip reinforcement, and then we can simply apply the pre-stress load, and that's it. Next slide. It is an enhancement in the material parameter. So we have introduced a new material parameter in case of for shear behaviors for total strain crack model and Mikawa-Fukura model, and it is a coefficient that is enhancing the equation below for the parameter FST. So now one can have more control on the shear behavior. Next slide. This is an enhancement in extended hardening soil model. In hardening soil model, the shear failure surface is a more Coulomb failure surface, and the flow potential surface was also more Coulomb. And now we have made an option so that one can change the flow potential surface from more Coulomb to Drucker-Prager type. And it is not a default or general option. We only made it available in the advanced feature. So that's it about this hardening soil model. We have an extension in the user supplied user BSL bond slip interface model, bond slip interface subroutine. The new parameter is the strain of the bar itself. So in a bond slip configuration, reinforcement configuration, we have the reinforcement itself, the bar, and we also have surrounding interface around it that connects it to the mother elements and also allows this slip behavior. And for some material behavior, it is also important to have the information about the strain of the bar. So now this extra information is there. Next. This is a new analysis. It is actually not very new. This equivalent linear analysis, it was already developed a few years ago, but in 10.9 we have made it official. The idea, its input is like time history analysis. So we give say this so-called time load diagram, but the solution strategy is different. It is first using a Fourier transformation. The input signal is taken to the frequency domain, and then the problem is solved in the frequency domain. And then with inverse Fourier transformation, we get back to time domain again, and we present the solution again in the time domain. Its advantage is that when it is solved, the main problem is when solved in frequency domain, we can consider structural damping, also known as hysteretic damping. This is only possible in frequency domain, but not in time domain. So in time history analysis, direct time history analysis, we cannot use it, but here we can. Another advantage is for fluid structure interaction, we can use the compressibility effect. This is again not possible in direct time history analysis. So, but also there is a downside, because in frequency domain, we can only solve linear problems. So if we have highly nonlinear material that we cannot account in equivalent linear analysis. So this analysis is meant more as a pre-analysis type tool. For instance, one can, being in linear material, one can judge, say, the effect of compressibility or the effect of structural damping. So it is more like a helping analysis before the final non-linear time history analysis. Next. This is a small feature in geomechanical stage construction analysis. In the past, there was no model selection. So all the results were presented all over the model, but sometimes it is useful to focus on some specific element set. So a model selection is useful. Here in a picture, you can see that we can only show the result in a particular element set or group. So one can concentrate on the interesting part of the model. Next. This is about incremental temperature and concentration result. It is, so a new result item. It is for incremental temperature and concentration. It is actually the showing or visualizing whatever input user gave, but apparently it is known to user. But when we have complex situation like a space function, then its visualization is interesting. So in the post-processing, we can also now visualize what was given as incremental temperature or concentration. Next. This is a parameter type output. In total strain crack model, we have possibility for damage-based Poisson's ratio reduction, but there was no output corresponding to this feature. So users could not know how and how much Poisson's ratio reduced. So now we have this Parami-Poisson, Parami-Poirid option for this purpose. We had Parami-Poisson, but that is meant only for the initial Poisson's ratio or when it had a space function on it. But this reduced part, we have now we have a separate parameter output. Next. This is Denis's term. Thank you.
Yes, so I continue with the documentation. So since Diana 10.7, like a year ago, that we released this new Diana online documentation portal that can be accessed through this website or via the help functions of Diana IE. What changed between 10.7 and 10.8 and now 10.9 is that the offline version of the documentation was previously part of the Diana installation. So in 10.7 and 10.8, we released this new portal for documentation, but we have the option for the offline users that don't have access to internet, and we gave this offline version as part of Diana installation. So now in Diana 10.9, we took it out of the installation and we place it in the download website of Diana. And you can download this documentation. So it's still in HTML5 format, but it can be used without internet. And to make a connection with Diana IE and the help functions of Diana IE, you will need to change the online help location in the preferences of Diana IE. Next slide. please. Regarding tutorials, we have 3 new tutorials since the last release. This is the tutorial that demonstrates how to apply radial and tangential loads to circular shapes, making use of the local element directions defined in the cylindrical coordinate system. Next. The second one demonstrates how to output interstory displacements in a model of a building, and also how to use node groups for an easier selection of the nodes in each story. Next. The third one is called composite laminated shell. So the tutorial demonstrates how to model this material with layered shells. It also shows how to input these different layers of the composite laminated, and explains the output that you get from an analysis. I think that's all on my side.
Thank you, Denise. So I'd like to thank you, Milat, Denise, and Tanvir for contributing to this presentation. And of course, I'd like to associate all our colleagues, especially the development team who has been working hard to deliver this 10.9 version. As I mentioned in introduction, any users with a valid subscription can now take advantage of this version. So you just need to go to our website on the download page, and using the credential that we have provided to you earlier, but you can also request it by writing to sales@DNICA. So using this credential, then you can basically take advantage of the latest version of Diana, which is always advised. Don't use outdated version, always switch to the latest version. Again, I'd like to thank you all for joining this webinar. This webinar, the recorded session of this webinar will be available within a few days on our YouTube channel. And I also invite you to register to our newsletter to basically be informed as soon as there is something new coming on from our side. There's a lot going on, so keep an eye on our website. Soon we will have more information regarding the upcoming technical webinar and online courses, for instance. So it's always good to register to the newsletter to be informed about our latest development. So again, I'd like to thank you all for joining this webinar about the new release of 10.9. And I'm sure that we will be sooner or later in touch in one of our upcoming events. Thank you all. Bye.